Welcome back to another video. Dr. Tarcia Huber here, and in this video we are going to be talking about the double angle identities. Yes, double angle for cosine, sine, and tangent. All righty, so we're just going to jump right in and start talking about what those identities look like. Okay, so double angle is when you know an angle and you want to double it. So any angles that we know that we want to double them, then these are the different double angle identities. Now, for cosine, notice the cosine of twice an angle is equal to, it has three different identities, okay? So the main one is this first one here. So the main one is this first one. The double angle identity is cosine squared A minus sine squared A. And all that is using the sum angle identity and making both angles A. And when you do that, you get cosine squared A minus sine squared A. So this is the main one. But you can get these other two, and you can probably think about how you can get them. You can get these other two by using the Pythagorean identity. So with the Pythagorean identity, we know that cosine squared theta plus sine squared theta, cosine squared theta plus sine squared theta is equal to 1. And then if we were to solve for cosine squared theta, we would get 1 minus sine squared theta. So if we took this cosine squared A and replaced it with 1 minus sine squared A, then that's where we would get 1 minus 2 sine squared A. And also sine squared theta is equal to 1 minus cosine squared theta, or in this case A. So if we took this sine squared A and replaced it with 1 minus cosine squared A, then we would get this 2 cosine squared A minus 1. So this is the main identity for cosine of 2A, or the double angle identity for cosine, but you can also get these other two by using the Pythagorean identity. The double angle identity for sine of 2A is equal to twice sine A cosine A. Again, that comes from using the sum identity for sine. And lastly, the double angle identity for tangent is 2 tangent A over 1 minus tangent squared A. And that also comes from using the sum angle identity for tangent with both angles being A. Okay, so these are your double angle identities. And so we're just going to look at how do you use these. So first example, we're given that cosine of theta is equal to 3/5 and sine of theta is less than 0. And so we want to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta, okay? And so one way we can find these angles is we need to first of all know, because the sine of 2 theta and cosine of 2 theta, those both involve sine and cosine. You see cosine of 2A involves cosine and sine. Well, you have one that involves just cosine, but if you want to find the sine of 2A, then you also have to use sine and cosine. So what I'm trying to get at is that we need to figure out what is sine first in order to find these first two, and actually in order to find this last one also. So we can find sine by using the Pythagorean identity. Cosine squared theta plus sine squared theta equal 1. And so we know that cosine is 3/5. So we will replace cosine with 3/5 and square that. That is 9 over 25. 3 squared over 5 squared. And then we will subtract 9 over 25 from both sides to solve for sine squared theta. All right, you will have to get a common denominator. Your common denominator would be 25. So 1 is the same as 25 over 25. 25 over 25 minus 9 over 25 is going to give you 16 over 25. And then you take the square root of both sides. And we normally take the square root to get rid of this square right here in the sine squared theta. And the square root of 16 is 4. The square root of 25 is 5. And I was about to say, normally you take the positive and the negative square root. But in this case, it tells us at the top that sine of theta is negative. It's less than 0. So this would be a negative 4/5. All right. So sine of theta is negative 4/5. And so you can figure out which quadrant you're in. Your cosine is positive. Your sine is negative. That means we're in quadrant 4. Cosine is positive and sine is negative in quadrant 4. So our angle theta is in quadrant 4. Alrighty. So now we want to find the double angles for sine, cosine, and tangent. So sine of 2 theta, if we go back and look at our formula, sine of 2 theta is 2 times the sine of theta times the cosine of theta. So twice sine theta, cosine theta. Well, now we know that sine of theta is negative 4/5 and cosine of theta is 3/5. And so you just multiply all of that. So 2 times negative 4 is negative 8. Negative 8 times 3 is negative 24. And 5 times 5 is 25. So that is your double angle for sine. So sine of 2 theta is negative 24 over 25. All right, now let's find cosine of 2 theta. So cosine of 2 theta, you can use any of those previous formulas. I'm going to use the one that only has the cosine in it just because cosine was given in the problem. And that way, if for some reason I happen to make a mistake finding sine of theta, I won't have 2 mistakes because I won't be using something that I made a mistake in. So I'm going to use just the one with cosine in it. So 2 cosine squared theta minus 1. So 2 cosine squared theta minus 1. We know that cosine is 3/5. So I'm going to replace cosine with 3/5. And that is squared. If I square 3/5, that's 9 over 25. That's a 25 in the denominator. 2 times 9 is 18. So that's 18 over 25 minus 1. Find a common denominator. That would be 25 over 25. And so 18 over 25 minus 25 over 25 is going to be equal to negative 7 over 25. So that would be our cosine of 2 theta, negative 7 over 25. Now we want to find the tangent of 2 theta, and we can actually just use, the sine and cosine to find the tangent. So tangent of 2 theta is going to be equal to, that's parentheses, the sine of 2 theta over the cosine of 2 theta. And we know that the sine of 2 theta is negative 24. Negative 24 over 25. And we know that the cosine of 2 theta is negative 7 over 25. And so this is equal to, remember when you divide fractions, you keep change flip. So you keep the numerator, which is negative 24 over 25. You change the division to multiplication, and then you flip the denominator, which would be negative 25 over 7. The 25s would cancel. You got 2 negatives, so it becomes positive. So it leaves you with a positive 24 over 7. And so the tangent of 2 theta would be 24 over 7. All right. And so that is how you would use the double angle identities when you're given one of the trigonometric function values. If you have any questions about anything we did in this problem, don't hesitate to put them in the comments below, okay? Let's look at another example. So for example 2, we want to simplify each expression. And so when we look at these, we want to be able to look at them and notice to see if they look like, of course, in this case, any of our double angle identities. But you do eventually need to be able to look at them and make connections to certain identities when you see them. So for example, on part A, cosine square 7x minus sine square 7x, that looks like one of the double angle identities, specifically the double angle identity for cosine. So cosine of 2 theta, recall if I go back to my formula, cosine of 2 theta, or 2a here, y'all see it's cosine square a minus sine square a. So it looks like this side of that identity. So the cosine square a minus sine square a. Well, we know that that equals to cosine 2a. Well, in this case, our A is equal to 7x. So I'm on part A. So cosine squared 7x minus sine squared 7x. That's equal to cosine of 2a. Well, a in this case is 7x. So that's equal to cosine of 2 times 7x, and that's a 2. So that's equal to cosine of 14x by the double angle identity. And that's like 14x altogether. So part A is equal to cosine of 14x by the double angle identity. Now, when we look at part B, it looks like the double angle identity for sine, but not exactly like the double angle identity for sine. So let me go back really quick to show you the double angle identity for sine. So we have sine of 2a is equal to 2 sine a cosine of a. So what is this one missing here? It's missing that 2 in front. So if we write sine of 2a equal to 2 sine a cosine of a, it almost looks like that, but not quite. It's missing that 2 in front. So what I'm going to do is divide both sides by 2 so that I know what that would be, what sine of a cosine of a would be. So I'm just switching the side that I'm writing it on the equal sign, but sine of a cosine of a is sine of 2a all over 2. Y'all see that? Because I took out the 2 out of that identity. So that means that sine of 15 degrees, and notice that our a here is 15 degrees, times cosine of 15 degrees, that's going to be sine of 2 times 15 degrees all over 2. Well, that's equal to sine of 30 degrees all over 2. And we know the sine of 30 degrees is 1/2. That's 1/2 over 2. 1/2 over 2 is the same as 10. Keep, change, flip 1/2 times 1/2, because you will flip the 2 and it'll become 1/2. And that would equal to 1/4. So our second one, sine of 15 degrees times cosine of 15 degrees, that would be equal to 1/4. Alrighty. If you have any questions whatsoever about what we did in that problem, don't hesitate to put them in the comments below. But that is how you will work those using the double angle identities, okay? So now let's do one more example. Example 3, we want to verify that the following is an identity. Cotangent of x times sine of 2x is equal to 1 plus cosine of 2x. So we're back to verifying. And now we can verify because we have some new identities in our toolbox that we can use. So we can verify more identities now. Alrighty. So remember, when you verify, you pick the side that's most complicated to start with. And in this case, the side that looks like it has the most stuff in it, to me, is the left side. So I'm going to start with the left side, the cotangent of cotangent of x times sine of 2x. That's what I'm going to start with. And then I'm just going to rewrite. I see this double angle in here. So I'm going to rewrite this double angle as 2 sine x cosine x. And that's by the double angle identity. And I'm just going to put DAI. That stands for double angle identity, okay? Now I'm going to convert cotangent, because remember, one of our hints was to always convert in terms of sine and cosine if you can. So I'm going to rewrite cotangent as cosine of x over sine of x. And do y'all know what that's by? How will we justify that? If you said the reciprocal identity, then you are correct. So that's by, I'm just putting RI because it's crazy writing on my screen. And so I don't even want to write out reciprocal identity, but that is by the reciprocal identity. And so now you notice that the cosine of x is canceled. I mean, not the cosine, the sine of x is canceled, and it leaves you with 2 cosine squared x. All right, now that's not quite what we want In our problem, we want 1 plus cosine of 2x. So notice there's a cosine 2x in there. Now, if I go back to my identities and I look at the one that only has the cosine in it, then I get cosine of 2a is equal to 2 cosine squared a minus 1. So if I think about that identity and using that, 2 cosine squared x minus 1 is equal to cosine of 2x. I just switched the side that I wrote I don't know why I did that, but I just switched. Oh, I know why I did that. I switched the side that I wrote them on the equal sign because I'm trying to go from 2 cosine squared x to incorporate a cosine of 2x in it. So here, if I wanted to go to get this right here, then I would just add the 1 to both sides. And so you get 2 cosine squared x is equal to, and in this case, I'm going to write the 1 first, 1 plus cosine of 2x. So now we can replace the 2 cosine squared x with 1 plus cosine of 2x. And that's by the double angle identity. And that's what we were trying to show, that cotangent of x times sine of 2x is equal to 1 plus cosine of 2x. And so we've done that, we've verified it, and we are finished, okay? So this is still what we've done in the past, verifying identities. It's just now we have new identities that we can use in the process, alrighty? If you have any questions about anything related to the double angle identities, don't hesitate to put them in the comments below and I will respond. Thank you for watching. If you like this video or if it helped you, go ahead and hit the like button. And if you haven't already, hit that subscribe button. Thanks for watching, and I will see you in the next video.